Let us explore two Lewis electron dot symbols and structure. To draw the Lewis structure for covalent compounds, we follow these rules or guidelines, we can say. So the first one is hydrogen is always a terminal atom, always connected to only one other atom. So for example, in methane, CH4, hydrogen is at the edges, you can say that is terminal atom. It cannot be like this. Hydrogen in between carbon and hydrogen, it is not possible. Okay, so that's what it means. Hydrogen and fluorine, both we will just take only as terminal atoms. And the second rule is the lowest electronegativity is the central atom in the molecule. So when you talk about the lowest electronegativity, here is another shortcut. Fluorine has the highest electronegativity in the periodic table of elements. So whoever is closer to fluorine will have more electronegativity compared to the one who is away from fluorine. Okay, that's a shortcut again. So if there are two elements competing, say for example, sulfur dioxide in SO2, how can we do that? Who is having lowest electronegativity in SO2? Sulfur and oxygen competing here, right? Who will be at the center? So sulfur is here and oxygen is here. So sulfur will have less electronegativity compared to oxygen. So sulfur will go at the center and oxygen as terminal. That's what it means, okay? And the third one is find the total number of valence electron for elements. So for ions, add for negative ions and subtract for positive ions. So what is that means is total number of valence electrons. So for methane, how many total number of valence electron? Carbon, how many carbon got? It is in the 14th group. So carbon got 4, third point, valence electrons, and hydrogen got 1 valence electron, but we have 4 of them. So then add them. So 4 plus 4, we have 8 electron. I represent electron E, negative S. So that means electrons, okay? So total number of electrons we got. And then what are we supposed to do? Divide by 2 to get the number of electron pairs. So how can we do this one in this particular example? It is 8 divided by 2, which is 4 pairs. Okay, so then what we will do next is place one pair of electron, which is a sigma bond, between each pair of bonded atom. Sigma bond means we are just putting a line in between the first line we are putting, that is sigma bond. Okay, so I have made another video for sigma and pi bond separate. Please watch that one if you want to know more details on that. But for drawing the Lewis dot structure, so we just put a line here, that is the first line is sigma bond. So we are connecting carbon and hydrogen through a single bond. One line means two electrons. See that one dash, a covalent bond is 2 electron. One dot is 1 valence electron. So one dash is a covalent bond, that means 2 electron. So I'm putting a line in between carbon and hydrogen, but that means a pair of electrons. So we have 4 pairs. So we are putting 4 pairs around the carbon and there are 4 hydrogen. So we connected all the available electrons. So we are done with drawing Lewis dot structure for CH4. So you don't have to follow all these things. So all these things depends on the molecule you are doing. So for CH4, we are stopping at stage 4 or rule 4. Okay. And now what is the other one means? Subtract from the total number of bonds you just used. So we don't have anything for that one. Say for example, if I have a water molecule, H2O, how many are there total number of valence electron? And we know hydrogen is the terminal, so I will put hydrogen and then oxygen and then hydrogen. Okay, so first I will do that one, and then if I know it, If I don't know, I will just do the total number of valence electrons. So hydrogen is 1, but we have 2 hydrogen here. So 2 plus oxygen is in the 16th group. So 6 valence electron, 8 electrons. So when I take half of that one, 4 pairs. So 4 pairs I have to arrange. Now I have only 2 here, that is bonding oxygen and hydrogen. That's a sigma bond, right? And now here it says subtract. Subtract what? Subtract from the total number of bonds you just used. So I have 4 pairs. So 4 minus 2 will be 2 left. 2 pairs I have. So what am I supposed to do with those 2 pairs? They are talking about place lone pairs, that is called a lone pair, and now it is not bonding because we don't have anything to put, because we cannot put more around hydrogen, only one element connected, and we cannot put more than one dash, correct? Okay, so place lone pair about each terminal atom except hydrogen. So I cannot put for hydrogen here. So what I will do to satisfy the octet rule, that means 8 electron around each element except hydrogen. Leftover pairs are assigned to the central atom. Okay, so now I have to put it on the central atom, which is our oxygen here. How many pairs? 2 pairs left. So I will put, see the 2 pairs I put on the central atom. So it depends on the molecule, you have to follow the steps. Sometimes we may have to just use few steps here. Sometimes we have to use all these steps. So then place the lone pair, I did it. If the central atom is from the 3rd period or higher, it can accommodate more than 4 electron pairs. So we will explain all those things when we go to each examples in the upcoming slide. So this is basically the rules are. And if the central atom is not yet surrounded by 4 electron pairs, convert one or more terminal atom lone pairs to pi bond pairs. That means we will just put one more. Say for example, let me show you. One more line which represent a covalent bond. That means oxygen. Say for example, oxygen molecule. So if I have oxygen molecule, I'm just taking a different color. 6 plus 6, that is 12 pairs. Sorry, 12 electron. So divided by 2, 6 pairs. Okay, so I will draw oxygen connected to oxygen. So I took only 1 pair, so 5 more pairs left. So 1, 2, 3, 4. I don't have, so I will just put here like that, right? So what I will do here is I'll transfer this one. We have 8 here, but we have only 6 here. So that's what it says. If the central atom is not yet surrounded by 4 electron pairs, so it is not. So I will transfer this one to this one, and I will put a double bond here. So one of them is sigma and the other one is double. And I will leave the other dots like that. Now you count how many are there. For each atom, do we have 8? 2 here, 2 here. 1 dash means 2 electrons. So 2 here and 2 here. So 8 and 2, 2 goes for this oxygen as well. And 2 here and 2 here, 8 for this one. So octet completed. And one of them is sigma bond and one of them is pi bond here. One of them is pi and one of them is sigma. That's what it means. Okay. All right, so we will try more examples and you will be more comfortable in drawing the Lewis dot structure. While drawing Lewis structure, we will use two vocabulary, lone pairs and bond pairs. What is that means is bond pairs are in between the elements that is bonded together, right? Whereas lone pairs are which is not bonded. It is non-bonding pairs. It's not bonded yet. No other element shared this electron. That is what is called lone pairs. And the bonded pairs are called, in between the elements, are called bond pairs. Let us see some simple examples to practice Lewis dot. So first let us take hydrogen here. So hydrogen is in the first group. So one valence electron. We have two of them. So 1 plus 1 equals 2 electrons. So one pair of electron, right? So we will just draw hydrogen to hydrogen. So that's a single bond and only one line in between these hydrogens. So we call it as sigma bond as well, which is represented by this way. Okay, so the next one is oxygen. Oxygen is in the 16th group. Look in the periodic table and you can see for oxygen how many valence electron it is here, 16th group. So we will have 6 valence electrons, right? Okay, so let us draw that one. 6 plus 6 because we have it is diatomic. So 12 electrons. So 12 divided by 2, 6 pairs. We just showed in the previous slide, but still that's okay. So oxygen connected to oxygen. So that's a single bond. That's a sigma bond. And now we have 5 pairs left. 1, 2, 3, 4, 5. It doesn't matter. You can put 3 here and 2 here and then transfer. It doesn't matter. Okay. So then one pair will go here because we have only 6 around this, only 6 electrons around this oxygen and 8 electron around this oxygen. So we have to make both oxygen satisfy the octet rule. So we are transferring these 2 pairs to the center. So we are getting like this. Okay, so this is the Lewis dot structure for oxygen molecule. So we have now 8 on each oxygen atom and one of them is sigma bond and the other one is pi bond, which is written as pi. Okay, so this is double bond. So that's about oxygen, and now the next one is our nitrogen. Nitrogen is, where is nitrogen? Nitrogen is in the 15th group. So how many valence electron? We will have 5 valence electron for nitrogen. So each nitrogen 5 valence electron means 5 plus 5, 10 total number of valence electron. So how many pairs are there? 5 pairs. So let us try to draw nitrogen connected to nitrogen and I took one already. So out of 5, I have 4 left. 2 pairs on that, 2 pairs on this. And now each nitrogen got 6 valence electron around. So we have to have 8. So what I will do, I will transfer one pair to the center and then I will have nitrogen double bond nitrogen and these 2 lone pairs are still there. So these are called lone pairs. Okay, I can put lone pairs. And this is bond pair. That's a name we give to those type of. Okay. Just to distinguish the colors. And now let us see, is that satisfying the octet rule? 2 plus 2, 4, 4 plus 2, 6. Only 6 electron around this nitrogen and 8 electron for this nitrogen. So both should have 8 electrons. So what it will do is, it's going to transfer this one to the center as well. So we will have nitrogen triple bond nitrogen and one lone pair here, one lone pair here. So we will have triple bond here now. So how many sigma and how many pi? Only one sigma always. And whatever we are transferring will turn to pi bond. So we will have 2 pi bonds. Okay, so that's the simple one to show single double and triple bond, and the lone pairs and bond pairs.